Okay, this is going to be chapter 21 for Physics 2 overview. I think this is I'm just gonna try to study everything in one take. So, isn't that gonna be fun? Ah, ha, ha, ha. So yeah, study along with me. Let's figure this out now. So we're starting out with a particle of a charge. So we have a charge. Let's see. It's a good start. Now whoa. Let's see, charge is like Q or something. So Q equals 4.2 times 10 to the negative 6. And then we have a distance, which is 12.5 cm, which I want to convert this. This is C, but this is cm, so I want to convert this to 0.125 meters, which I believe is the correct conversion. So from this, we're asked to find the magnitude of E. Let's see, I'm gonna quickly try to pull up the PDF for chapter 21. Because it looks like we're just gonna need it looks like we are just going to need a equation for this, and then it should be good. I have to open up the thing as like a PowerPoint. Dang you, PowerPoint. You slow software. I've got a little laptop over here off to the side. You guys can't really see my screen, but I'm trying to download chapter 21 as fast as I can, but the SharePoint PowerPoint thing's really, really slow. Very bloated, very not well designed. Just running into a visual bug, I guess, right now because everything's still half loaded. There we go. Finally, I'm getting it downloaded as a PDF. We're just given a charge. Aha, we're not just given a charge and a distance. We're given another Q1 and Q2. Negative 1.1 times 10 to the negative 6c. You finally download this presentation. I'm going to open up that in a PDF document because using PDFs through web browser is just a little bit slow. I won't lie, just a bit slow. This is chapter 23. Error. It's probably not downloaded yet. Now, do I try opening it now? Is this downloaded now? So, yep. Perfect. Okay, so this one's all Coulomb's law. So that's going to be like K equals, oh boy, absolute value Q1, Q2 over D. Is that just with over R? So we're asked to find E, but I guess what we could say is we're asked to find F. This is in newtons. Newtons is force, so what they're asking for now is just to use Coulomb's law. So this is going to be K, absolute value Q1, Q2 over R squared. Ooh, that R looks bad. R squared. So plugging all this in, F equals 8.99 times 10 to the 9th, since K in this case, K equals 8.99 times 10 to the 9th, known as Coulomb's constant. And we're going to multiply this by 4.2 times 10 to the 6th times 1.1 times 10 to the negative 6, I meant to say. And then this whole thing is going to be over 0.125 squared. Let's see what this gives us. Now remember, both of these are times 10 to the negative 6. So since its absolute value is just going to be 4.2 times 10 to the negative 6 times 1.1 times 10 to the negative 6. And that's going to be over 0.125 squared. And I am getting 2.658. So let's see if that's right. Yep, that's correct. Perfect. Let's move on to the second one. I think I'll just keep doing the... You guys get to see how I set it up too now. Oh no. And then... that's going to be what that looks like. So in the figure below, the particles have a charge Q1 equals minus Q2. Okay, we can just start listing the Q's then. Q1, Q2, Q3, Q4, and Q1 equals negative Q2 equals 225 and C negative 225 and C Q3 255 negative 255 and C, which we can convert all of these to standard coulombs. I think this is times 10 to the negative 9th. And now we also have a distance, which is 6 cm, which is 0.06 m. Why don't they just give us things? Let us solve the problem. Stop giving us tiny things to solve. Gosh, oh, it just gets so annoying. Let's see. And what's the x component of the net force on particle 3? Okay. The y component of the force. Well, since particle 1 is entirely... we just need to find the x and y components of particle 2. So it's just going to be particle 1. So it's going to be Q1 plus Q2. So this is going to be for... oh, we should do x first. going to be Q4 plus Q2 cosine theta. It's going to be for x. And for y, it's going to be Q1 plus Q2 sine theta. And since these are, it's a square, it's just going to be it's a 90-degree angle. I'm assuming these two are going to be 45. 45 plus 45 plus 90 should be 180. Yeah, so now we know what theta is. So now this is going to be, and let's just go to program or apps 0 and unit converter and do length. Is there nano? I don't know what n my is, but what's n my to my? Hey Google. It's probably actually a real thing. You probably say hey Google and it'll probably give you nano coulomb to coulomb. What's nano? Times 10 to the 9th? Negative 9th? Yeah, it was. Okay. So now this is going to be, well, actually, no, I say. I might be doing this all wrong, but I don't know. Would x therefore be a Q4 Q2 cosine theta over, and here's the thing, what's r now? We've got an r from here to here. We've got an r from here to here. Would r then be r1 plus r2 squared? It would be r1, r2 over 2 squared. It would be like the average. Ain't this a fun question? Well, I've come to a point of, I don't know if it's a lack of understanding. Well, I know that it is lack of understanding, but I've come to a point where I am uncertain, a point of great uncertainty. So now I shall totally just Google this problem. In the figure below, particles. And let's see what the wacky, crazy internet has to say. Windows update. My computer is gonna restart in 5 minutes. Well, I better get this done quick then. Thanks, Windows update. Oh my gosh, Chegg with the graffiti. This is not the computer for this. You're chugging. Yeah, it's not Chegg, it's chug. My computer is crawling now with all the graffiti you've loaded. I can't click on nothing on this web page. Oh, was it worth it? Did I say Chegg? No, I didn't mean that. Haha. I didn't mean that. You guys didn't hear it. Mm-hmm. Haha. Okay. How they're doing this now. A whoosh. And all of this is gone. Everything is quiet. What they did is they just did, well, okay. Well, we have this. I said, okay, well, we have a Q 1 and 3, right? That's just Y. Be Q 1 3. We have a Q 4 3, which is this. That's just X. Then they did Q 2 3, right? And this one's X and Y. And we know that this side's A and that side's A. So what they did is, oh, Pythagorean hypotenuse theorem, sonny boy. Okay, this is going to be 2A, isn't it then? Let's see, A squared plus B squared equals C squared. So would that really be 2A? Because what they did for A is they made it times 2. Which I guess this could make sense because 5 squared plus 5 squared is 50. So if A's 5, hypotenuse is 2A. Yeah, no. How am I supposed to make sense of this? Why is it times 2? The other ones aren't. But it's times 2 squared. Just A squared. A squared A. Ah! I thought that it would be 2 square root A. Right? Isn't that? Let's see. R squared equals A squared plus B squared, then R equals. Well, I mean, if it's A twice, just A squared plus A squared, so then R equals the square root of A squared plus A squared. Can you do anything with this because there's a plus sign? I don't think so. But maybe because you're taking the square root of this, then, oh, that's square root of squared, so then it just becomes R equals A plus A, which means that R equals 2A. So I guess that's your proof there. Although I don't think it holds up because, oh, there's the computer restarting. uh, yeah, I just don't agree. Because there's a freaking plus sign. You can't manipulate equations with addition or subtraction. Simple wombology. But let's proceed anyway. Against my better judgment. That's fine. K of Q 3 and 3. So F 3 equals K. F's the value Q1 Q3 all over A squared, which is 8.99 times 10 to the 9. And it's going to be 225 times 10 to the negative 9 times 255 times 10 to the negative 9. Right? Let's say Q1, 225, and Q3, 225. Or 255, 225, 250. And all this is going to be over A, which is 0.006, or no, 0.06. And we're getting a force of 0.143. Now let's do F. Let's see. 4, 3, which is K. You know what? I'm going to do a magic trick. That won't save me no time at all. Is this supposed to be an eraser? What? What's happening with the brush? Oh my goodness. Okay. Whoa, I saved so much time by doing that. How worthless. This is going to be Q1 is. No, it's 4, 3. Aspect ratio saved my life. Four, 3. And 4 is, well, it's the absolute value. So it's going to be 255, 225, isn't it? They're just going to swap places. So 255 for 4, and for 3, it turns out actually 3 is still 255. So it's just going to be 255 twice. 0.162. And then the fun one, 2, 3. How much time I saved by doing the thing I did last time over this strategy? Well, let's see here. This is actually going to be 2a squared, and it's going to be split up into sine and cosine for x and y. This is going to be, I'll have to write this one out. Okay, well, let's do it for x and y. X, k, q2 cosine theta, q3 2a squared, and y is going to be k over q2 sine theta q3 over 2a squared. How fun. Fun and fancy. I think that's right. Why wouldn't it be? And then we just have to take Fnet. Fnatic jet. No, actually, we might get different values here. Let's roll with my idea. It's the best idea I've ever had. And I learned something just now. I typed in times 10 to the ninth instead of times 10 to the negative ninth. Do you think that has an outcome on the answers, or is it just going to be magnitude? Looks like it's just magnitude. So what we could say now instead, haha, ha ha ha, is this was secretly always. Well, you know what? It don't matter. It don't matter. I did type it in as times 10 to the ninth. I lied. I made it all up. I make things up all the time. 8.99 times 10 to the ninth times alpha y equals of cosine 45. That was Q2, and Q2 is 225, and Q3 is 255 times 255 times 10 to the negative ninth. And all of this is going to be over 2 times 0.06 squared. And here's the funny thing. Cosine 45 and sine 45 are the same number. Corporate wants us to tell the difference, and it's the same number. So you know what that means? That means this is 0.05, and this is 0.05. Oh, but wait. That's x. We've got to add that. It's going to have to be plus f 4,3, and this is going to have to be plus f 1,3. Let's see what our final outcome is. 0.14 plus 0.05, 0.193, and then 0.16 plus 0.05, 0.213. For some reason, none of this looks right. Oh, it looks bad. It looks bad, man. Bad. Ooh, where did I go wrong? How could this happen to me? Where is that mistake I've made? Well, let's try it anyway. 0.193. 0.213. And yep, they're both wrong. So let's try something very slightly different. If and instead we take this number straight and then multiply it by cosine 45 after, it should give us the same. It's the same thing. So my way didn't change that one bit. No, where did we go wrong? Let's see. Those numbers look bad. This is f23x, f23y. Our f23x and our f23y look good. Check and check. What about our f? What about our f1, 3, and 4, 3? F1 looking good. F4, why isn't it lower? Could be lower, couldn't it? Let's nudge it. We've got K, yep. We've got $255 twice, right? 4, 3, $255 twice. Hate to admit it. But it looks good. The problem must be in the summation. Why aren't you? I can't erase this. What? What in the heck? Well, all that stuff's phantom stuff, but that stuff's erasable, I guess. I'm haunted by the past, my failures, my mistakes. It's unending. So let's do a summation. What they want is f net, and f net is f1 plus f2 plus f3, etc. Now get this. If we're adding x and y, well, think about this. In just the x direction is f4, 3. In just the y direction is 1, 3. Did I mistakenly add 1, 3 instead of 4, 3? f1, 3 is all y. And I added it to, well, here's the thing. It doesn't matter which one I added it to, since f2, 3 and f2, 3, x and y are the same. So it really doesn't matter outside of swapping. 0.19 should be the y direction. And I put it on x. So maybe let's just swap those numbers around. I got 0.213, right? Okay. Negative. Something's wrong. I've got the y. I got the y value right. So this plus f1, 3. Check. This plus f4, 3. Wrong. What's the difference? Same procedure for both, right? What's the difference? I'm going to take the absolute value of 255. It's 255 times 10 to the negative ninth times 255 times 10 to the negative ninth. Since it's the absolute value, it doesn't matter that one's negative and one's positive. They're both positive in the absolute value. And then you put that over a squared like I did all the rest. And that is indeed the answer. The distance is a, right? Distance is a. No. I got the x right. X is 0.2. Y is 0.91. Is it 0.914? Is that what they're looking for? Or 194? Boy, what is the issue with that one? I'm doing it the exact same way. Well, let's see. It's not that it's not that I've got x. Let's really go back. I've got something confused. So x is 0.213, and to get x, I did 0.16 plus f of x. 0.16 is 43, which is x. Plus f 43. Check. And y should be plus f13, which is wrong. So in the positive x direction from the origin, I'm adding. From the positive y direction from the origin, I'm adding. That's not my flaw. That is not my flaw. Wait. Do we need to figure out what the positive particle is and the negative, since the positive always goes towards the negative? Particle 3 is positive. With positive, negative, negative. Q4, Q2. So when I did x and y, I did positive to positive, which should repel. So they add. But when I'm doing the force here, positive to negative, mayhaps it subtracts. And if that's the case, I'm going to put in a negative 0.0926. That's it. We got it. It's because it's repelled. Well, here's the funny thing. If it's repelled, then the force is going in the negative y direction here. Right? Which is what we're seeing. F of y is negative 0.0. And then in the x direction, they're attracted and is in the positive x direction. So that's why this one here is a positive 0.213. Look at that. How much learning just got done. On to the next one. Boy, I got Chris Ledoux songs stuck in my head. I ran out of mouse pad. Oh boy. What do I even... Just... Goodness. Alright, I know what I have to do in these situations. Okay. And then we've got... that there. In the figure, particle with charge of 1. Let's just say Q1. Particle 1 with a charge of 1 yuck. Particle 2 with a charge of negative 3.3 yucks. And these are all going to have to be converted. Isn't that everyone's favorite? And we have a distance, they call it L, of 12 centimeters. Oh my goodness, we have to convert more. If particle 3 is unknown charge is to be located such that the net static force from particles 1 and 2 is 0, what must be the coordinates of the particle? Okay. So, unknown charge, so we don't even know if this is plus or minus, to be dead honest. This is interesting. So it's gonna have 0 y, because it's asking x and y is gonna be 0. But what's the x gonna be? Okay, well, Coulomb's law, let's see. Well, let's have to set k absolute value of q1 and q3 over L, I think, or is it L plus X? Equals K Q1, Q2, Q3, all over. Same. Shouldn't it be the same? And if you cross multiply, we're going to get K Q1 Q3 times D plus X equals, it's gonna be so funny, isn't it? Why is math working out like this? K Q2 Q3, whoa, straighten out, boy. D plus X, watch this, watch how funny this is. DX's cancel out, K's cancel out, so we're left with absolute value of Q1, Q3 equals the absolute value of Q2, Q3. So plugging in both of these, we're getting Q1 Oh, they got Q3 on both sides, so Q1 equals Q2. Where's the flaw? Where's the flaw in the math, boy? Where is it? It's the absolute value. It's just gonna have to be positive Q3 and positive Q3, and then they cross out. Q1 doesn't equal Q2. Unsolvable problems, what I see in front of me. Unless there was a logical error in the very beginning. But we know that it's going to have to be d plus an unknown distance, then d plus an unknown distance for the other one. And when you set them equal to each other, that just cancels out. K just also cancels out. And then Q3's on both sides, that just cancels out. What is wrong? All I can think of is the distance is only applied to one of them, but here is the thing, right? It's going to be x1 and x2, isn't it? There'll be, no, it would be the same distance from both, right? I have it charged here and here and here. I don't know, maybe it does cancel out here. Maybe this distance cancels all three out. The whale. Oh boy. So, if we make an x1 and x2, check this out. One unknown, two unknowns, three unknowns, one equation. Can't do it. Move this off to the side just so I have something to remember it by when it's all gone. Well, internet, help me out. In the figure. They all start with in the figure. There's a video of it right there. But I'd rather look at a textbook. Well, in that case, I could look through the lecture notes. Isn't that the funniest thing you'd ever heard? Look through the lecture notes. Ah! Oh, it makes me laugh. I looked through the whole darned electric. I looked through the whole darn slide. There's nothing. Yeah, I guess I'll just have to look through the internet. Hello, internet. Hmm. So it is not between the two charges, is it then? Unless... Hmm. Yeah, maybe I'm thinking about the problem wrong. Maybe instead of these being our two and that being our new one, maybe that's the new one. Then how would this make this net? Wouldn't it just take more off of this one? Like, these two have a force, right? And if I just put this here, maybe it wants to pull it that way, which would, I guess, that would weaken this force. And if that force is weakened, then this could be net zero. But wouldn't it be the same anyway? Like if I had a magnet, here, and it was really close to this old CRT, right? If I had this magnet here, and it's just slurping on this, and I was like, oh no, I have to fix this. Let me get a really strong magnet and do this. And then these magnets start slurping. I'm not going to save this monitor. This CRT is cooked, right? It won't be like introducing this magnet makes this force suddenly null. Am I thinking about it wrong? I don't know. It's a really good question. I will write down for my teachers. I'm gonna start wording this then to ask it properly. Homework number 3. This is for chapter 21. Does introducing charge on one side of a particle take charge away from the other side, unless they're meaning the net of the entire system is 0. So if I had these 3, so these two, say that there's a charge of 2, very heavily charged, and then I introduce another particle, and it's this way, and then this one has to be a charge of 2. Now this one has 2 in the negative direction and 2 in the positive direction, making this one 0, and if that one's 0, then this is 0. Oh my gosh. It's a guy. He's taking a nap. He's sleeping. Okay. Is that what they're asking? If particle 3 of unknown charge is located such that the net electrostatic force on it from particles 1 and 2 is 0. So no. What it's asking is particles 1, particles 2. Okay, they have a force. This now needs to be the reverse of that force. But we don't know its charge. It could be positive, could be negative. That's the tricky thing. But all that would determine is what side it's on, right? If this is negative charge, then that has to be positive, and if that's a positive charge, then this has to be negative. Because that makes this 0, and that makes this 0. See, these are the questions I should have been asking when we went over this chapter in the first place. I hate past me. I'm always paying for his sins. Hate that guy. Always left foot in the bill, whatever that means. What does it mean? Why'd I say if I don't know what it means? I mean, I used it in the right context, but what does it mean to foot? It's like I'm doing anything. Am I stepping on it?
Yo.
Oh, break time. 10-minute break.
Session over.
And the break is over and we're back. You guys have a good break? Shoot. Alright. So I think I know how to get at this now. I shouldn't have been working over the break, but I was. I'm sorry. I apologize. Even though I know it's lies. So we know how to get F. I'm trying to find how you get E. Then it would be EZ. It doesn't even say. I'm gonna Google it. Coulomb's law energy. Q1, Q2 over R squared. Come on, man. That's just standard old Coulomb's law, man. I guess E and F are the same thing. Equals KQ2. That's what I'm not understanding about this. Is they are always breaking it down in these worked examples into KQ1 and KQ2 when the form is K absolute value Q1, Q2. Everywhere you look. Everywhere. So now what I must do is watch a video. Here, you guys can watch it with me. You guys can't hear it. I apologize. Okay, so they cancel Q3 on both sides. Shouldn't they also cancel K on both sides? Yeah. Why didn't anyone in the why didn't anybody in the stupid chegs? Alright, that makes sense. They just didn't fully do the thing. Okay. So now we can set again K Q1. I knew it. I was dead close. I was dead close. Yeah. Okay, I got it. K cancels out. Q3 cancels out. And I'd almost say X cancels out, but it don't. So for Q over X squared equals. It's gonna not be, it's gonna be 2, 3. 2. X plus D squared. So now, goodness me. $36 probably really good size for that. I wish I could learn the ability to stop and think for a second. And plug our values in now. We're gonna get, boy. What is a uke to a C? Negative. Union scientific notation. Yeah, Dunder Mifflin. So it's micro to standard. I can just look up that. just times 10 to the negative 6. And then it's going to be 0.12 meters. Perfect. So we're getting 1 times 10 to the negative 6 times x plus 0.12 squared equals negative 3.3 times 10 to the negative 6 times x squared. Now we just probably can put that right in there, can't we? 1 times 10 to the negative 6x plus 0.12 times 10 to the negative 6. Well, I had a stupid idea. Now that I've done this. How about this? The art of math. Square root of, it's a negative number. God, wait, no, it's the absolute value. We're good. 3.3 times 10 to the negative 6 times x. We just took the square root of both sides. We can divide this by x. And then, boy howdy, wouldn't x just cancel out and we're left with a number times a number and it wouldn't mean nothing? Wouldn't mean nothing. We just get a ratio. I'm getting that's what I'm getting ratioed by this problem. Well, what kind of voodoo did they do? Looking at this Chegg thing, I'm starting to wonder. So what they did is they just swapped these. And how does that work? It's like a magnet. It looks much better. And this is now equal to, what's this gonna be? Q2 over Q1. It's just, how nice is that? How much nicer is that? But that's not the same as doing cross multiplying. So what technique is this? What technique? Keep, change, flip? Keep it? Change it? Flip it? Ain't no way that's keep, change, flip, son. This ain't second grade. Okay, you know what I think they did? Let's try it. Check this out. Q1. I don't have to write absolute value. This is gonna be some witchcraft. Q1 times. This looks like an R, sorry. X plus D squared equals Q2 x squared. Divide this side by Q2. Divide this side by x plus d. We're left with two goes on the bottom. We're left with Q1 over Q2 equals x squared for x plus d squared. Elegant. Elegant. Why couldn't I see that? Why couldn't I see that? Now I gotta remember. Wait a sec, but that's not what they got. Because it's a ratio, you can flip them, can't you? Well, here's the thing with the ratios. I think because it's a ratio, you can just flip them. Right? But 1/2 is not the same as 2 over 1. But 1/2 equals 1/2 is the same as 2 over 1 equals 2 over 1. That is where you can flip them. Why wasn't I in 3rd grade when I thought of that? Pay attention. Q2 over Q1. And this is just to get it in the form that I'm seeing it in commonly. And we can now just plug in data. That's absolute value, so it's just 3.3 times 10 to the negative 6 over 1 times 10 to the negative 6 is going to be equal to. How do you express this out? It's going to be x plus d plus x plus d, or times x plus d. It's going to be x squared plus 2dx plus d squared. Yep, x squared, xd again, d squared again. Okay, I'm going to do it that way. And this whole thing is going to be over x squared. Now, here's the thing. Since it's x squared, you could write it as x times x, which removes that x term, gets rid of that, it gets rid of this. Does that work? Is that possible? And then these cancel now, because there's just an x. It doesn't seem real, but why can't I do it? What's stopping me? What is stopping me from saying that is x squared is x times x, and therefore all the x's go? Oh, it's so simple. It's so simple. Oh, dang. You know how they did it? Dang, there's always something more elegant. Yeah, I don't think mine works. I want to know why it doesn't. Okay, get it, right? They have x squared, and they have x plus L, or x plus D squared, right? Because this was squared. Because this was squared, it all goes away. Now, wait a second. We go back to mine. If I called this x times x, those cancel out, right? This is what I said. Square goes away. And then we can write this as d times d plus 2d plus 2d. Wait, how does that one work? Who knows? All I know is we have x plus d over x squared. So elegant. Or it's d plus x, x plus d. What's the difference? What's the difference? And then what do they do? Square both sides? And square root? Square root of the answer of that? They do too. So let's do the same. So this is going to be just over 1. This is just going to be 3.3 square root of 3.3. Getting 1.81. Now 1.81 equals x plus d over x. Multiply this, it's going to be 1.81. X equals x plus d. Now subtract an x. That don't work out like that. Can't, because that's x minus x, but it's going to be something times x minus x. No, no, no. So we're here. We can plug d in. Now we got 1.81 x minus 0.12 equals x. What do we just divide both sides? Here's the thing. If we just divide by x, we won't get it in terms of x. If we divide... Dang, what the heck? Teach me your ways. I'm just gonna restart this whole entire thing. I am so sorry. I'm just gonna restart everything. Gotta move much faster. Move much, much faster. I'm wasting too much time. So, what we know is k over f value q1, q2 over r squared. Okay, this is gonna equal k of q2, q3, let's call this q3, all over r plus, let's call it L. I'm not gonna just switch it for no reason anymore. Squared. Okay, now k's cancel out, q3's cancel out, and we have q. This guy, the WNY tutor, he's got a much... I like his way much better. I do. Yes, I do. So it's just gonna be right up here even, save some space. q1 for x squared equals q2 x plus L squared. This is an x the whole time. Okay. You ready for how the WNY tutor does it? Square root both sides. What you're going to realize quickly is that the times 10s cancel out, just as if they was a variable. So we have 1 over x squared equals the square root of 3.3 times x plus L squared. And by the end of this, it becomes 1 over x equals square root 3.3 over x plus L. Now, we have square root 3.3 x equals x plus L. Look at this. Let's plug L in. Let's do it. Do it. Does it want the answer in centimeters or meters? I didn't even actually check. It wants it in centimeters. So let's actually keep it in centimeters. How about this? X plus 12. So from here, we just subtract x. 3.3x minus x equals 12. And then what? So now He didn't. Ah, okay, okay, okay. He took x out and made the square root 3.3 minus 1. So now what? We divide this by... That should be our answer. Let's see. 12 over square root 3.3 minus 1. Boy. I'm getting 14.69. And of course y is going to be 0. Yep. I am going to have to put a big star on that problem. Chances are I'll never see it again. Gotta love it. Yeah, not this again. Not this again. Anguish, anguish. You know, it's funny. Last session, I felt like I was gonna throw up, and then I ate some hot wings, or a hot wing. Now I feel great. That's a motto for life. Put on a gravestone. It's a funny thing. He put something. He put something on a gravestone to live by it. Oh, jeez. That's funny. It's just funny. All right. Figure below. Goodness me, this monitor is extremely freaking out of focus. I have to focus it. Figure below shows 4 identical conducting spheres that are actually well separated from one another. Sphere W, initial charge of 0 is touched to sphere A. They are separated. Sphere W is touched to sphere B. -32e, and they're separated. And the sphere W is touched to sphere C. And they are separated. This freaking daisy chain and a hot dog. What's E then? What the heck were you trying to solve? E? Q1, Q2. So we want to end up with a charge. Okay, so the force is given. Write it down. F equals K absolute value Q1, Q2 all over. I don't know. R squared, I think is what they call it these days. But when you touch the spheres together, that's 0 squared. You're left with just KQ1, Q2. And I hope I'm seeing this right. Oy vey. Okay. Let's try it then. So we have a first interaction, our first one, which is WA. It's going to be 8.99 times. I'll just write it as K. It's K. Q1, Q, W. What, 8.99 times 10 to the 9 times charge 1. Charge A, sphere A. 32E. To charge, so WA. So this is going to be 32E equals K times Q1, which the initial charge is 0. So you'd think then it would be 0, but we don't know what Q1 is. But anything times 0 is 0, and we're dividing by 0. Oh my gosh, we're dividing by 0. Ha! What kind of retard am I? Thinking that would ever happen. So then, if the distance is 0, does that mean the equation doesn't work anymore? What the world? What in the world? Let's go into the PowerPoint that's been relatively useless. Of course, everything I've needed has been in there, but not presented in such a way that I have been finding useful. Maybe I'm the problem. Maybe I was always the problem. I do not got all day. No, I do. I don't want to. I don't want to waste the all day that I have. So, is it even worth me going into the notes and trying to find some nonsense gobbledygook when I can just look up this exact problem and get this exact information? Yep, that's what I thought. It's exactly what I thought, in fact. I thought it here first, folks. And in fact, I'll just watch the WNY tutor talk about it. I think he's got a video on this. Short little 5-minute video.
and we wish to determine the charge on each sphere. It's a rather simple matter. If we do it to get the charge on each sphere,
Rather simple matter. Screw that guy. One simple for me. Divided by 2. Ah, that is simple.
You want to bear this concept in mind. Question. So in the first phase of this question, we are going to bring sphere W and sphere A together, and we're then going to separate them. Now, the initial charge on sphere W was stated in the question 0, and the initial charge on sphere A is known to us. So what we do when we separate the two spheres, one, is we follow the idea from before. So for example, on sphere W, the amount of charge present is going to be the original charge on W plus the original charge on
2 unknowns, 3 equations.
Of course, this can simplify since 0 plus QA. So on sphere W as well as on sphere A, we have QA. Next, we're going to touch spheres W and B together. We already noted the charge
QA times 32E over 4.
So then we separate the two spheres, and we're going to come up with an expression for the amount of charge present on QW. Again, we simply sum original charges before they were touched, and then divide by 2. Notice in the numerator we have added a negative.
Wait.
Now we have a complex fraction here. You can see
okay.
Complex fraction if we multiply every by 2. The reason that works nicely is because the 2 in the numerator right here and the 2 in the denominator. So that's going to leave us with a minus 64 all divided by. This is the charge currently. Finally, we touch
Multiply it by 4. Multiply 64 times 4. 4 times 4 is 16. 64 divided by 4.
So we'll sum the original charge.
40 over 16.
Plus original charge.
No, not 240, right? 128. 248.
Let's multiply each term by 4. The 4's here will cancel. And so in the numerator, we're going to have QA minus 64E plus, this will amount to 192. And then in the denominator, now, if you look carefully in the numerator, we have like terms plus the 192E. So when we do so, we get plus 128. This is the final expression for the amount of charge present on QW for all phases of the question through. Now, the question notes that the final charge on sphere W is plus 18E. That means you can take this expression.
Set it equal to 18? Yeah.
Now our goal is to solve for it. And one way to do that would be to put a 1 underneath the 18E and fraction on the left side equation and fraction on the right side of the equation. We can multiply those two guys. Set QA plus 128E. And QA. And the final step to solving for QA would be to subtract 128.
Now, did I learn? Or did I just have the appearance of learning? It's always the question to things that are gained easily. Just do the same thing. QW equals QA. Initial charge unknown. cannot read that screen if you're. W has an initial charge of 0. QA brought to QW, which is brought to 0. QW equals QA over 2. Do the same thing. For now, I don't know, Q. I did A. What does it say? Not A is brought to B. There's sphere W. This is going to be QWA. Q the Warner Brothers. QA over 2 minus 32E over 2 QA minus 64E over 4 QWC equals QA minus 64E over 4 plus 46E, all this squared. QA minus 64E plus 46E times 4. 40. 46 times 4, my boy. 184 then. Eight. 23. Well, hold on. $184 minus 64 is 120. Over 8. And it said that QW's 20. 20E equals QA. It would be QA over 8 plus 120E over 8. Or I should probably leave it as QA plus 120 all over 8. Then multiply both sides by 8. And then it's going to be 160E equals QA plus 120E. And then we just subtract 120E from this, giving us 40E equals QA. Is that even close to what the... Oh, he got something slightly. Let's try it. 40. Got it. Thank you, tutor. WNY tutor. That's actually did so well this time. It really came through for me on this day. What's the overall concept? When things are brought together, you add them up and divide them by 2. That's the concept? That can't be the concept. But it is. Is it just to see if we can understand that would be this as simple as this concept is? Or maybe it's a useful skill, but jeez. Oh boy, this one's a crazy one. I'm just gonna do this. It's so crazy, I have to do something crazy just to match its raw energy. Unfiltered chaos manifest. Okay, so excess charge. Cat? Excess charge? I don't know, I'm just gonna call the charge I have excess charge just charge. Q1 equals negative 5.6, which is negative 5.6 times 10. It's 10 to the negative 6. Yep. That's just gonna be a coolum now. Cool. How many electrons are transferred between you and the cat? Well, if I'm 0 and it has an excess of 5.6, it would either be all of it or half of it. Well, not quite. K equals Q1, Q2. Well, we don't know the distance, so it can't be that equation. Don't just go thinking that's what it is, says I. The only freaking equation in this whole chapter is K. Q1, Q2. Other than Q is knee, and is 1, 2, 3, so with an elementary charge. Yeah, that's just what E is. Charge is N E. N is what? Doesn't say. Well, it does say N is 1, 2, 3, dot, 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 so it's just the summation. Could have just written that then. So it must not be just the summation. And that's it. It's just the same 5 equations. Electric force, charged objects, coulombs. We're not given enough information for that one. So for the other one, we add them up and divide them by 2. So 0 for the person, net charge is 0, no extra charge, plus that number divided by 2. Wouldn't that just give us the number halved? How many electrons are transferred between you and the cat? So you take the charge the cat gives you, which we just learned from the last problem. You add them up and divide them by 2. So this would be this number divided by 2. And now what? Electrons. It's going to give us coulombs. Coulombs are some kind of a unit of, I believe, force. And we're asked to give a quantity of electrons that make up that force. How many electrons are in a coulomb? Well, what is a coulomb? Is there any way to go backwards into the electrons from coulomb? We know E is, well, let's write it then. First off, half of 5.6. It's gonna be 2.8 times 10 to the negative 6c. We know that E is 1.602 times 10 to the, what is it, negative 19th. Yeah? So how many of this number is in that number? How do you do that? Well, we can divide one by the other, can't we? Divide this. It's going to be 2.8 times 10 to the negative 6. Divide by 1.6022 times 10 to the negative 19th. And I'm getting a crazy number. I'm getting 1.74 times 10 to the 13th. I'm going to call it 1.75. And it's wrong. And I don't believe it's wrong. Is it negative? No. Because it's not quite half, is it? How do you know if it's... how do I know that it's not quite half? It should be. There's no reason it shouldn't be. 0 plus that. I just explained it. I ain't gotta explain it twice. But it's wrong. And I don't see quite how. I'm within a ballpark. And NE, Q equals NE. That is what I found. So excess charge Q. What is N? N is what we're trying to find. Do we just... Is it just 5.6 times 10 to the negative 6? I swear. 3.50 e to the 13th. I was right. In my initial guess. It's not times 2. It's all of it. It's either half of it or it's all of it because it's excess charge, I guess. How does that work? There. That's part 1. And it says, in the spark, do the electrons flow from U to the faucet or vice? Oh, wait. Faucets now? You will gradually discharge it via the floor, but instead of waiting, you immediately... Dang it. All right, time for another 10-minute break. Okay, sorry about that. It took a little bit longer than I expected. Okay. So yeah, instead of waiting for it to discharge, you just go when you see. So if you have more charge, you're positive. It's gonna go from you to the faucet. Just before the spark appears, do you induce positive or negative charge on the faucet? You're gonna induce a positive charge. And if instead the cat reaches a paw toward the faucet, which way do electrons flow from the resulting spark? Well, the cat's neutral now. So let's say the cat. There's a spark. I don't know. It's going to always be from the cat to the faucet, wouldn't it? No, it'd be from the faucet to the cat. So if instead the cat reaches a paw towards the faucet, is it because... Well, geez, why is that now? The cat's going to be neutral. The faucet's going to be ground. That doesn't make sense. There would be a spark. The cat has more positive charge now. Okay, so I guess because the cat has less electrons, the electrons jump from the faucet to the cat. If you stroke the cat with bare hand on a dry day, you should take care not to bring your fingers near the cat's nose. You will hurt it with a spark. Considering that cat hair is an insulator, explain how the spark can appear. Well, they can't repel, right? They'd have to attract. Have to be those two. Yep, so let me just quickly fill those in then. Just visually before we go. So it's gonna be that one, that one, that one, and then those two. Yep. Almost done with this entire chapter. Okay. I guess I should have a picture of the figure then. Just like that. You guys can't see it, but on my CRT there's major ghosting, and it's honestly just a little bit funny to see a trail like a shooting star behind my mouse cursor. Yep. Q1, Q2, Q3, Q4. Yeah, I want this one in meters. That 3 looks ugly. Well, no. Q1 equals Q2, but Q3 does not equal Q4. Turns out there's no Q4. The greatest lie that Q4 ever told. Okay. Particle 3 of charge Q3 is moved gradually along from x-axis, x equals 0 to x equals 5 meters. Change in x of 5 meters. I guess I'll say that delta x equals 5 meters. I would assume we're trying to find the magnitude of the electrostatic force on the third particle from the other two. What values it will be minimum and maximum. So we need to know the position and the, well, this seems an awful lot like problem 1. Position of minimum force. So how do we know what the minimum force is? Well, just graphically, just plain out graphically. The most force would have to be where the particle is the closest. So I'm going to say that position of minimum force. Boy. Position of maximum force should be 0, but it just isn't. Completely lost. So we know Coulomb's law that force equals K Q1 Q2 all over R squared. I'm just going to do Q1, 2, and Q2, 3. But we've got a change in R. We don't know where its max or min is. I can't just sit here and guess and check. Yeah, all right. I thought about it. Now, if I just set R to be 5 and R to be 0, we have to solve for R. Okay? Because we can't guess and check that. But then we also don't know F. And we'd have to guess and check that. We can figure out F if we know R. We can figure out R if we know F. It says maximum and minimum. So it's going to be... Open up the notes. Them notes never help no one, none know how. See, they're doing something goofy here. They're trying to find an angle. And then they are taking, looks like the derivative. Just the Western New York tutor. Does she have a video on this? I sure would appreciate if you did.
डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का मिनिमम मैक्सिमम और मिनिमम मैक्सिमम जो फोर्स हमें क्या फाइंड आउट करना है एक्चुअली हमें ये बताना है कि एक्स की फोर्स होगा क्या होगा इस डायरेक्शन में आएगा।
Well, here's the problem that I have with how these peeps are doing it. So we're saying that point C. No. Particle 3 is gradually moved. So it starts here and it's gradually moved to here. And we've got particle 1 and particle 2. What I see everyone do is, oh, let's just do this. It's this, so, and then what we gotta do is then we gotta find this angle here. Well, here's the problem. That angle isn't the same as this angle now. Is it? Certainly not the same as this angle. So theta is constantly moving. So if it's constantly moving, we don't know its position. We don't know what it's going to be. Why would you take that? Why would you take that angle there? At that point, just take that R. You know what I mean? Might as well just do everything at 5. Then might as well just do everything at 0 and say, oh, well, that's what it is at 0. That's what it is at 5. Answer somewhere in the middle. Call it good. No. So why take the angle at its maximum?
हमारे पास 2 3 डिवाइडेड बाई आर स्क्वायर आर क्या है दोनों के बीच की डिस्टेंस उसका स्क्वायर करेंगे एंड एक्स स्क्वायर प्लस डी स्क्वायर का स्क्वायर करेंगे तो रूट बढ़ जाएगा यहाँ पे क्या बचेगा यहाँ पे सिर्फ बचेगा एक्स स्क्वायर ये हमारा f2 वैल्यू है। इसी तरह से अगर पॉइंट और 3 के बीच में पहले यही फोर्स आने वाला है यही फोर्स हमारा आने वाला है यहाँ पे देखो तो हम कर लेते हैं f1 ये हमारा f2 की कारण जो 3 फोर्स है वो f2 था पॉइंट 1 के कारण जो पार्टिकल 3 फोर्स है वो हमारे पास क्या था f1 यहाँ से देखोगे f1 हमने निकाली f2 की वैल्यू अगर फाइंड आउट करोगे तो उसकी वैल्यू क्या होगी k 2 3 डिस्टेंस क्या है एक्स स्क्वायर प्लस डी स्क्वायर स्क्वायर करोगे तो रूट आएगा यहाँ से क्या देख पा रहे हो जो फोर्स एक्स की दोनों फोर्स के बराबर है एफ के बराबर इसी वजह से हमने यहाँ पे एफ लिखा था। यहाँ पे देखिए अगर सिमेट्री से देखेंगे एंगल थीटा है एंगल थीटा है तो ये थीटा होगा तो ये थीटा
I'm not really absorbing a lot of that. I'm going to tell you what. I'm getting kind of mad. I'm going to open up that worked example, this worked example. I'm going to look at that worked example, this one, and that one. Just as much as money can buy. And I think I just watched that YouTube video. But there's this worked example and that worked example. Mm-hmm. It looks like they did. Would they find their theta to be? Does it even matter? Okay. Okay. I'm getting a few worked examples now. This one's a killer. This problem is a killer. Is there anyone that just makes it simple? Like, look, this is a long, complicated problem with all these fancy steps. This step is that. This step is that. I'm liking this one so far. Almost, if I can get my head around that one. Boy, that one you can mess up quick, though. Real quick. But it's simple.
Point towards the next charge. So over here at point P, we should draw a vector pointing directly at. Perhaps we can call that electric field. For positive charges, electric field will point away from it. So over here at point P, we would project an electric field vector that's pointing away from charge stuff. And we can label this electric field E positive. It will next be useful to superimpose an over. What we'll do next is take the electric field that we mark E positive, break it into Y components. For its X component, projecting up along the next direction. Y component straight up, positive Y direction. And perhaps we can label the X component E positive X. E positive Y. We'll do a similar.
I'll just try to follow along to this. Oh, that one's got an angle too. It says theta is the angle between the x and y axis. You idiot. Yeah, it's just gonna be 90 at all times, and why do we have to take it at that point? Because was it sine 90, and then yeah, that's 1, cosine 90, and then yeah, that's 0. So is it? I don't get it. And at the end of it, they still get cosine theta is. They're getting, okay. They're getting theta as a variable, which I agree. You're going to need to take it as a variable. How? How do we get to that point? How do I see it? Go, oh yeah, it's that. It's how it slots into place. They're jumping right into, so they got just Q1 and Q2, and then they're jumping. Snap right into F3 cosine theta plus F3 cosine theta is F3 equals K Q1 Q3 over D squared plus X squared. Where'd D squared come from? Where'd X squared come from? Where are you getting these? Where'd they come from? You dunder mifflin. So we know what D is. Distance from the x-axis. Distance from axis, and then distance along x-axis. We don't know y-axis, do we? No. The distance at y is the distance from the x-axis. D is dy, and then x is the distance from y. Distance from y, distance from x. Yeah, okay. But still, what's that give us? Sine is square root d plus square root delta x. And they called that r squared. They should square root that whole thing. But instead, cube root it. Now, why cube root it? Should be r is the square root. We know that r is the distance there. We found that by taking the hypotenuse of the x and the y. So then y is at cube root over 2 even. I'm just not following along. You know what? I'll have the teacher go over this one in office hours. Just go over homework number 6. Splendid. Let's just move right on to another problem. I get just about one of those a chapter, one problem that I can have the teacher go over. And hopefully this one's nice and easy. Oh, what? How did I just disable both? Control V. Control V, how did I copy both? Hit E, get this out of here. Looks nice. Okay. Calculate the number of coulombs of positive charge. Oh, that's funny. It glitched out. Wait. That's how it works? Oh, that's really neat. I didn't realize that is how my pen tablet worked. Yeah, the tablet doesn't have a pressure sensitive thing. It's the pen. Pen's pressure sensitive. So if you move the pen near the tablet and then you press in on the pen, you don't actually need to even touch the tablet. It's very neat. It's very neat. I didn't know. I've had this for a while and I never knew that's how that worked. I still wonder how it works. This pen doesn't take batteries. How does it communicate? Well, regardless, just write something down. I'm taking way too long. Centimeter cubed. How do you get to centimeter cubed to meter cubed? Is this going to be 412 cubed, m cubed? I don't think so. I don't think so. I think so. Cubed. It's going to be 412 times 10 to the negative third meters cubed. Don't look right, does it? Ooh, -6. I was kind of right. I was on the right track. Oh, it looks like a G. I wonder why I was on the right track. I can't explain that. Maybe I wasn't on the right track. I just got lucky. It's water. Hydrogen atom contains 1 proton. Oxygen atom contains 8 protons. I have a feeling what this is saying is that 1 H2O is 1E plus 8E equals 9E. That looks like a 4. 9E. And we know that E is that stupid 1.602. Completely nonsense. But I can still do 9 times that number. And maybe I get some less. So this means that H2O becomes 1.44 times 10 to the negative 18. Okay? Okay. And this is going to be E. How many number of coulombs for positive charge? Well, how much H2O is in 1 meter cubed is 1 liter? How many, goodness me, is this going to be moles per liter is H2O? And then moles. Oh, no, it won't be moles per liter. Let's see. Yeah, moles per liter. Moles into electrons. Right? This isn't physics. This is chemistry. Am I on the right track? Okay, moles is given mass over atomic mass. Oh boy, the atomic mass. Hydrogen's got a mass of 1, right? That's weight. Weight of 1 point. Yeah, it's the same thing as mass, right? Weight and mass are the same thing, right? And oxygen. Gold number 8. See its density. See its weight 16. So let's see. 1 H2O. 1 plus 2 times 16 is 32, 33. 33 moles over the given mass. We don't have any mass. No mass was given. But wait. A centimeter cubed of water is a gram of water. We have 412 grams of water. It's not the formula. It's not the formula in any way. The atomic mass is 18. I take it all back. The atomic mass is 18. So we have 412 over 18 is the moles, which is 22.88. What's Avogadro's number? Okay. So now we do this times 6.022 times 10 to the 23rd or something. Yep. And this should give us the electrons, right? Or no, this should give us the total number of molecules. Okay, so now we do this times 10, we should get the total number of protons. I'm getting an absurdly large number, 1.37 times 10 to the 26th. Coulombs of positive charge. Is it 1 point? At 1.4 times into the fifth. Okay, something's deadly wrong. WNY tuner, look at you go. No, I guess this is reality.
Water, of course, has the formula H2O.
Yeah, he's setting it up awesomely. I like this. So we've got 412 centimeters cubed of water. 1 gram of water is 1 centimeter cubed of water. And 1 mole of water is 18 grams of H2O. Okay. And now for moles, we'd probably get the total number of, what's it called? Molecules per mole. And then 1 mole is 6.02 times 10 to the 23rd. And then from there, there's 10 protons for every molecule. Where do you go from here? That's kind of where I was when I left off. Now it's an electron. So it's using classified as coulomb per proton. Then this one thing is going to be 1.6 times 10 to the negative 9 coulomb per 1 proton. Okay. Centimeters cancels, grams cancel, moles cancel, molecules cancel, P cancels, and we're left with just coulomb. This is going to be 412 over 18 times 6.02 times 10 to the 23rd times 10 times 1.6 times 10 to the negative 9th. Try it. We've got 22.8 times 6.02 times 10 to the 23rd. Now we've got 1.378 times 10, 13.78. And this is actually going to be 1.378. It's going to be times 10 to the 26. It's going to be times 10 to the 25th. Now this whole thing here multiplied by 1.6 times 10 to the negative 9th. And we're getting 2.006 times 10 to the 24th. Ah ha ha ha. Ah ha. It says it's wrong. So how? How is it wrong? I did it. I did everything right. Except. I divide by 18 early on. No, I did that right. Oh gosh. I mean, NY tutor, you darned lied to me. Total number of coulombs of positive charge. Coulombs of positive charge. He did. Let's see if I get the same answer. He did 250 divided by 18. Then he did times 6.022 times 10 to the 23rd. Then he did times 10. Then he did times 1.6 to the negative 9. Or 1.6 times 10 to the negative 9. He got... Oh, I'm getting something way different than him. Let's run this back one more time. So we got 250 divided by 18. He's got 250 divided by 18. Multiply it by 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd. Multiply it by 10. It's negative 19th, not negative 9. I'm getting something still wrong from his... How? 250 divided by 18 times 6.02 times 10 to the 23rd times 10 times 1.6 times 10 to the negative 19. Got it. What was different? Eight point 8.36 is because I did 6.022 instead of just 6.02. Shouldn't change the answer that dramatically, in my opinion, but it does. It changes it a ton. Just do 6.02, not 6.022. Who the heck invented 6.022? So now, if I do 412 divide by 18 times 6.02 times 10 times 1.6. I'm getting... Here we go. I'm getting 2.2046577. All right, we got it. Yeah, just don't write 6.022. That's it. Chapter 21. chapter 20 done. Let's do the same thing for the next chapter. So excited. And this is just the homework problems. I still haven't even gone over the lecture problems. Two particles are fixed on the x-axis. Oh, come on. Really? Jeez. Hate it. Hate this problem. Q1 and a Q2. Negative 8.5 times 10 to the negative 7 coulomb. And then we have positive 8.5 times 10 to the negative 7 coulomb. And we have x equals, oh boy, is it 38? 38 centimeters. 0.38 meters. Okay, it's just gonna look like, I don't know. It's gonna be Q2. And this is gonna be Q1. And they're saying that right between these, we have to find what E is. So what is E? Let's look in the chapter notes. Sorry, I'm trying to download the PowerPoint. Just like the chapter 21, it's just taking a fortnight. Okay, downloaded. Okay, we know what's chapter. This one's chapter 22. Okay. E equals FE over Q. Well, that's worth. Well, no, let's keep looking. Let's keep looking. Aha! This is what I was looking for. E equals KQ over R squared. You know where this would have helped? Here. Because now, KQ over R squared, all we have to know is that E1 equals E2. And we could just use KQ equals R squared. And then it would just keep us from having to cross out Q3. And then just a very slight time saver. But yeah, let's say they want to know K. We know Q. We know the overall distance is X. Okay, so this one's C equals 6. So this one's 0.06 meters, and this one's 0.38 meters, and then what's in between those two? So oh, time for the 10-minute break. Okay, we're back. Good break, good break. Yep, okay. We were 0.38, 0.6. What's right in between 0.38 and 0.6? I would say add them up, divide them by 2, get the average. That average would be offset by 0.06. Let's see. Why is this? Oh my goodness. Why is this so laggy? Okay. Oh, dude, it's bad. It's like 5 frames a second. 0.38 minus 0.06 over 2. Oh, dude, no, no, no. I cannot deal with that being that. Unplug you. Then plug you back in. Look at that one line. In one frame, it does not jump to there. It's smooth by the end of it, but it's the lack of frames that are killing me. I don't want to see my scribblings load in. Control-Delete, dude. There's no possible way that I'm using up any of this system right now. NVIDIA Quadro graphics. Let me just look at what you do when I do this. Oh yeah, that's floored. From what? What's using up all my graphics? OBS, you're not even recording in like a high res. What's the dealio? Yeah, you're recording at 30 FPS and like a low res. I have to stop you for a second. Get your act straight, bro. Okay. Yeah, I wanted to add them up and divide them by 2. But I might need to subtract them because it's going to be offset. Oh boy. Now I'm getting 3.16 meters. I don't think my computer's throttling thermally. Let me check. Um, I don't want Cupid or CPU ID. I don't think so. Hardware info. That's what I'm looking for. Yeah, wait. Okay, I think it's opening now. I'm gonna move this back up. If anything's redlined, I'll have to like stop the recording or something. But if not, I'll just deal with it. Here we go. Graphics card looks maximum. Okay, I don't think it has enough information yet. So that's all looking really good. That's looking cold-ish. A little bit warm, but that's not bad. It's not like 100, so. Okay. Oh, that's bad. It's so annoying. Okay. Is that midway? Does it make sense that that's midway? Okay, let's try it then. So if I have 10 and I have 20, in between it is 15. So if I do 20 minus 10 divided by 2, I'd have to add 6 to this. This is actually going to be 0.76. And let's make sure that, oh my gosh. Let's make sure that works with everything. So now if I have 20 and 30, if I do 30 minus 20, I know in between them is going to be 25. I'm going to get 10 divided by 2. And we're going to add 20. That's 25. So doing that way, I can probably simplify it. But it always gets me in between. Now, what if I just instead add them and divide them by 2? It gives me 25 here too, and then 20 plus 10 divided by 2 gives me 15 there. That scares me. It scares me. Adding them and dividing by 2 gives you the average. But is that the center? Is that in between them? Why not? Why not? I'm going to say why not. So I could just say we added them and divided them by 2. Part of me screaming that's wrong. Oh, I'm going to watch a video just to that point and then no further until I get stuck again. The graphics card seems to have calmed down quite a bit. Looking good, yeah.
Divided by the distance from the charge And if we call that E1, we might as well call this charge Q.
So if I do it my way,
Now
21
the
plus
positive
6
charge
divided by
demanding
2,
of the
halfway
point
should be
located
13.5.
we noted positive will produce electric away from the point. So if we were situated at this point, we would want to draw an electric field that points away from that positive charge. Away from the positive charge at this point would be left. We can call this electric field. And therefore we'll call this charge Q2. We'll notice that both electric fields are pointing in the leftward direction. So to get the overall electric field, we simply have to add these two magnitudes electric fields. And so we set up the following equation that the net electric field will be the sum of the magnitudes of the two electric fields. We're going to be following this equation for each electric field. So for example, for the electric field produced by particle 1, we would have K multiplied by our calculation. So the x-coordinate of that midpoint, which we might call xn, would simply be the sum of these two x-coordinates and then divided by x. And so if we do that, we'll have 27 divided by 2, which will be 13.5 centimeters. So that's going to be the x-coordinate of the midpoint.
Okay. Yeah, I was right. And I accidentally learned more of the problem than I wanted. So it's asking us E net is E1 plus E2. Yep. And we know E equals KQ1, so we have K Q1 over R squared equals K Q2 over R squared. Now it should be the same R. Actually, E1 plus E2. E net. So now we can also say that E net. Like graphical errors too, like right there. A Q. Well, what he did is he just recognized that this is the same on both. We did K over R squared times. Well, you can probably just do this. So then this is going to be, well, we know what that is. What's R? Is R squared going to be middle? It's be 8.99 times 10 to the 9th. All over 0.76 meters times I mean, it would essentially be this squared, right? Let's see if that's right. 5 plus 5 is 10, and then 5 squared is 25. It's not the same thing. That's something times itself, not something plus itself. Okay. What if I make sure this is in performance mode? Need double sure. Okay. Goodness me. I'm getting negative 201.09. I have wrong. Well, what's wrong about it? Everything's right. So I got it right. What's wrong? 201, 201.09. Yeah, no, I got it right. It's dealio. Unless I'm misunderstanding what R is.
0.075 meters.
I am. Okay. I'm getting well. Getting negative 40 to 18 I hat. Wrong again. Now I'm really not getting it. Okay. Check, 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 check. I got it. Come on. Oh, it's squared. It's squared. Okay, this is for sure. For sure. Negative 105.837. Ha ha. Calculator, you've got to stop being made of slippery plastic. Okay. Now for sure. K over R squared times a positive value of Q1 plus Q2. Wait a second. That's where I'm wrong. boyo. So, from here is xm. Nope. We're getting what we should get here Okay, so let's think about it. We got the distance in the middle. Now we want to know how far the distance in the middle is from this point. So you take B, and you take A, and you do B minus A, which is 0.76 minus 0.06, which is 0.7 is R. So now ha ha ha. Negative 31189. Ha! Wrong. It's squared. What's wrong this time? Okay, the only thing that can possibly be wrong is the R value. And he gets his R value from doing 13.5 and subtracting 6. 7.5. I'm getting mine from 0.76 minus 0.06, which is 0.7. My R is correct. And everything else is correct. Wait a second, did I just forget the I hat vector in this? Wrong, sir. Wrong. Ooh. So, I know that's right. I know that's right. That's right. That's right. That's right. And if I just do 0.7 squared, that's right. I got the problem right. So then now what's wrong? Because it ain't on my end at this point, bub. Let's try. So it's 8.99 times 10 to the 9th over 0.7 squared. And then it's 8.5 times 10 to the negative 7 plus 8.5 times 10 to the negative 7. That's the problem, boy. Nothing wrong with it. 38. 6. Do 38. Add 6 and divide it by 2. It's 22. Wait a second there. 0.38 plus 0.06 divided by 2. XM equals 0.22. Subtract 0.06 from this. R equals 0.16. How does this happen? How did I get the numbers I got? And if that's the case, this number don't look right at all. But none of them have 9, 6. Or negative 5, 9, 6, 9, 9, 2. Got it. Boy, the K1000's actually just chugging. Oh, let's quit some of this stuff. That's all I can do. Doesn't do a thing. Is there a program that's hung in the background that I can't see? Nope, it's all looking good. Okay. As far as like I've already done this one. Was there something dead similar in the... Oh. No. Oh. So we've got... First off, you can get rid of this. What? What is that? I do this. I'm gonna do that. You kidding me? Graphics glitch, I guess. So. Yeah, that's in the program. Maybe it's just not my monitor. Okay. Q1, Q2, Q3, Q4. Q1, Q equals Q2. So this equals E, this one equals 2E, 2E. And we have A equals 6.85 meters, micrometers, which we want the answer in nanocoulombs, so it's probably just going to be in meters. This is going to be 6.85 times 10 to the negative 6. saying point P. So we've got this right triangle. And we know that theta is going to be 45 degrees. And we know it's length A, length A. We know this is going to be a square root 2 in terms of length. With all that known, we're supposed to find the magnitude. Is it going to be something? Boy. Like EA cosine theta? No, it won't be that. Oh boy. Magnitude. Well, let's just do what we did in the first one. It shouldn't really be any different. Let's see. Yeah, we're gonna have it's gonna be the force. It's theta. And Q1 and 2, they're all positive. 1 and 2 is positive. Every bit of this is positive. So I don't think it would make any use to the force of Q1 and 3 and then force 2 and 3. That would be the force in the x direction and force in the y direction. You'd think. So then what can we do? Now I can take the force in just the x direction and the force in just the y direction. And knowing x and y and theta, oh boy, that wouldn't make one difference at all, because 45 degrees sine and cosine. And it's strictly in the x direction, strictly in the y direction. Funny word. Funny couple words thrown together. Well, I can't just sit here and do nothing. Is there any examples in the lecture that looks like this? Well, E1, E net. Okay, Q1, Q2, Q3. R. Well, that's what we can do, I guess, then. Let's recognize that this is the same thing. This is going to be half. One half a square root 2. That's what r equals. For all of them. C1 and 2 are going to be the same then. So E1 equals K R Q1, etc., etc. And this is going to be 1.6 times 10 to the 20. Ooh, gosh, dang, what the heck was E? What was E? (1.602 times 10 to the negative 19th. Times 1.602 times 10 to the negative 19th. Be over A. Are we given what A is? Yeah, we are. So A is going to be 6.85 times 10 to the negative 6th. Okay. Okay. I'm not entirely in love with this answer. And am I sure that a microcoulomb becomes, or micrometer becomes 10 to the negative 6? Yep. So that means that this must be true. 2.1 times 10 to the negative 4th. And 2E2 be the same as E1. E3 be 2E, right? There's no Q4. I don't know why I say Q4. Ah, you're uninvited to the party. (4.2 times 10 the negative 4th). Now we just gotta do summation, am I right? You give us E net. And the direction's gonna be 45 degree. Now it's just gonna be pushing away in every direction. It's just straight up the E net. 2.1 times 2 plus that 8.4. Oh no, something's wrong. Ha ha ha. Oh, something's really, really wrong. What'd I do wrong? You son of a gun.
Are going to cancel out. And so they will not be.
Wait, E1 and 2 cancel out? Wouldn't they be adding? Doesn't say the P is negative, does it? Well, I guess they cancel out because they're in the same line of action. I should have saw that coming.
Any relevance to our calculations of total volume. What we're going to do is actually take out charge 1 and charge 2, since again their electric fields go out. And so only charge 3 is going to be producing net electric field at point P. And again, since it's positive, that net electric field will be pointing away from this direction. And our job is to find the magnitude in the direction. Now we know that for a point particle, the electric field is equal to a constant multiplied by the magnitude of the charge divided by distance squared. Now the distance would be from the charge to whichever point we are interested in. In this case, that is point P. So the distance that we need in this equation is going to be this distance right here. We call that R. And in order to find that distance R, we want to consider the isosceles right triangle present. You can see from the diagram that one leg of the triangle is A and the other is also A. And it turns out that when you have an isosceles right triangle, the hypotenuse of that triangle is always going to be one of the legs multiplied by the square root of 2. And that is always true for any isosceles triangle. Remember, isosceles means that the two legs are equal. So, given that this hypotenuse is A square root of 2, if you look over here, that would be this distance here all the way over. Now, point P is located exactly halfway along that hypotenuse. So that means that this would be half of A square root of 2. And so we label that distance accordingly. Now we're going to use Pythagorean theorem to find this distance, because we have a right triangle. Smaller right. Let's go ahead and apply Pythagorean. And so one leg of that triangle, we would have R squared plus the other leg. Other leg is A bracket 2 over 2. And that's going to equal the hypotenuse. Hypotenuse of the small orange right triangle is A. Now to simplify the expression in the parentheses, we would have to square the A. The square root of 2 squared just becomes 2. And in the denominator, we would have that switch. Now this can reduce if we divide top and bottom by 2. 2 will become 1. We can subtract both sides of this by A squared over 2. And so on the right-hand side, we would have. But we actually couldn't solve this R by taking the square root of both sides. But it might be more advantageous to leave this as squared. Let's remind ourselves why. Recall that the electric field equation has R squared in the denominator. And since we solved this equation for R squared, we can actually take this expression directly.
Oh.
Our electric field would be K times
I did it twice. Gosh, I hate the lag.
Now, to divide by a fraction, you can use something called heap change flip. Keep the numerator the same. You change the division to multiplication, and then you flip that fraction to over.
Okay. I'm just gonna throw throw in some nonsense, see what happens. Yeah, that one's wrong. Here's the thing though. Chief. Home slice. Wouldn't this length and that length be the same length? They are.
Now this can reduce if we divide top and bottom by 2.
Oh, well, no, they don't have to be. So, yeah, I see. So knowing that 1 and 2 cancel does make this problem quite a bit easier. So that's this equation here. But don't simplify no further. Of course, could rewrite this as a squared over, yeah, multiply everything by 2. This would just be a squared plus a squared times 2 over 4.
Here in the denominator. And we actually could.
And this just becomes a squared over 2.
So our here in the 2. And we actually could solve this 2. And then in the denominator, we would have to square that 2. Now this can reduce if we divide top and bottom by 2. 2 will be 1. We can subtract both sides of this by a squared over 2. And so on the right-hand side, we would have a. And we actually could solve this for power by taking this.
Oh, yeah, okay, I see what I did. Yeah, this is going to be a squared over 2. Because the hypotenuse is a, and I made r the hypotenuse, but it's clearly not the longest side. That was my bad. So now we have r is a squared over 2. We have that. Okay. Actually, hold on. Oh, you son of a gun. Ha ha. You know what it was this whole time? It was 1/2 a square root 2 freaking squared. This whole time I had the answer. I had it as 61. It was just 61 times 2. The answer is 122. How'd I do that? That was pretty sweet. Shift. That's pretty freaking sweet. Wish I knew about that before. Okay. E act be the actual magnitude. By how much is the ratio E apparent? Less than 1? Okay. So those are both equal to E, so we just set them equal to each other. 1 all over 2 pi epsilon 0 qd over z cubed equals 1 over 2 pi epsilon 0 times p over z cubed. I'm pretty sure those just straight cancel out. So we've got qd over z cubed equals p over z cubed. That can't be as easy as this one gets, can it? And then we have to plug in okay. Z equals 4.5D that's all we know. So we can now say that QD over 4.5D cubed equals P all over 4.5D cubed. That means QD equals 4.5 D cubed. And that means, or no. QD times 4.5 D cubed equals D 4.5 D cubed. QD equals P? What went wrong, son? What went wrong? I don't know, man. I have to look into this problem. I think I have it written down somewhere. I have to go over it. Make it clearer in my head. We have to be able to solve for something, though. P and QD, I can't get them out of the equation. Well, shoot. Either way. Four and a half hours, I think it's going to be my first session of the day. I'll take a small break and flip through the notes and then come back. Yeah. So, all right.